Example 5, verify. When you look at this thing, it's kind of hard to tell which one is the more complicated side. I don't know, maybe the left side. But when I look at the left side, I don't really see any identities other than I know I could change everything to the sine says. So maybe that's where I start. Okay. Secant alpha would be 1 over cosine alpha plus tangent alpha would be sine alpha over cosine alpha. You don't know how to make an alpha. Imagine making an x but not picking up your pencil. Okay. On the bottom, you've got another secant alpha, so another 1 over cosine alpha, minus another tangent alpha, so minus that sine alpha over cosine alpha. Pretty complicated looking fraction, a lot of stuff going on. Okay, but when I'm dealing with fractions, you should notice here that you've got a common denominator. Okay? You've got a common denominator of cosine alpha, and so you should be able to combine those two fractions into one expression. Up on the top, you're going to have 1 plus sine alpha over cosine alpha. On the bottom, in the same way, you combine those fractions, you get 1 minus sine alpha over cosine alpha. And at this point, I hope that you could see what's going to happen. Okay? What's going to happen is those cosine alphas are going to cancel each other out. Okay? I hope that you don't have to do this work, but if you didn't see why that happens, you're dividing fractions, and so you could think about multiplying by the reciprocal. Multiplied by the reciprocal, maybe that's a little bit easier for you to see why those cosine alphas cancel out. But either way, if you show your work or not, you're going to get 1 plus sine alpha over 1 minus sine alpha. Now keep your eye on the prize. Now you're always trying to notice the other side and see how you can reconcile what you've written with what the other side says. And it's kind of hard at this point to see how those things are going to match up. Okay? And so this example says working with both sides, so they want us to go over and work on the right side for a while. I definitely do think the right side is more complicated than the left side at this point, but I'm not so sure that's the easiest way to do this. Okay? So let me show you what I think maybe we would do. This 1 minus sine alpha on the bottom, we know one of our hints says with that 1 minus sine alpha on the bottom especially, we should be able to multiply by 1 plus sine alpha over itself. I think that's going to be a good thing for us to do. That would give us 1 plus sine alpha squared. So 1 plus sine alpha times itself. And on the bottom, we have 1 plus sine alpha times 1 minus sine alpha is 1 minus sine squared alpha. It really, really helps to know your algebra here for some shortcuts. If you don't know algebra, you're going to have to FOIL this stuff out. And I don't think anybody wants to do that. Okay. Now again, you want to look at what you have and how you can reconcile that with the other side. Are those two things equal? And maybe we could see that they are equal. Hopefully we can plan ahead there. But if you actually expanded that top out, 1 plus sine alpha, okay, so we've got 1 plus sine alpha. Maybe I shouldn't have condensed it. Maybe I should have just FOILed that together. If I look at it as quantity times itself, when you FOILed that together, you're going to have 1 times 1 is 1, and 1 times sine alpha. You have sine alpha plus another sine alpha, so there's plus 2 sine alpha there. And sine alpha times sine alpha is plus sine squared alpha. That looks familiar. That's what the numerator says. And then on the bottom, you have 1 minus sine squared alpha. well, we've seen a few times before, use that Pythagorean identity, that's cosine squared alpha. So they're a perfect match. I just did what I needed to do.